Hello, 5th graders, and welcome to a read-aloud of today's science ebook titled Stars, as needed for today's Unit 5 Lesson 3 science lesson, also called Stars. So what have scientists learned about the stars? Let's read to find out. Reading pages 4 through 27 in the ebook today. So because it's a good number of pages to read, everybody, please know I'm only going to be reading the main body of the material on each page. A lot of these smaller things like the captions on the pictures, I'll probably skip over those, but remember that you can always read those yourself if you wish. So with that, starting here on page 4 with Starstruck. Have you ever looked up at the night sky and been amazed by the scattered twinkling lights? You're not alone. People have been captivated by the stars for thousands of years. Some were so starstruck that they studied their every move. Early stargazers learned the stars could provide useful information. Ancient Egyptians planned their lives around Sirius, the dog star. Egyptian farmers knew that they could plant crops in the moist soil after Sirius rose in the sky. The ancient Phoenicians navigated the seas using the night sky. They learned the annual patterns of the stars. At certain times of the year, the sun and the stars would be at fixed distances from the horizon. They used their fingers to measure the stars' positions. The Greeks named the stars after gods, heroes, and animals from their stories. The Chinese from the Han Dynasty grouped the constellations by the 4 directions: east, dragon; west, tiger; north, tortoise; and south, scarlet bird. The Native American Tiwa tribe named the Milky Way the Endless Trail. They saw the constellation Orion as Long Sash, a hero who led his people away from their troubles on the Endless Trail. So people all throughout human history have been studying the stars and been fascinated by them. Modern-day astronomers use powerful telescopes to see stars. They also use satellites. Computers and other instruments help scientists learn what stars are made of, how far away they are, and much more. Astronomers have learned that there are different kinds of stars. Some are hundreds of times larger than our sun, which, remember, our sun is a star, while others are much smaller. Stars come in a range of colors: blue, red, orange, yellow, and white. Their temperatures and distances from Earth range wildly as well. Some stars are closer to Earth than others. The sun is our closest star. By studying the sun, astronomers have learned many things about stars. The sun is about 150 million kilometers, or 93 million miles, away. Flying in a jet plane, it would take you 17 years to get to the sun. The next closest star is Proxima Centauri, at a whopping 40 trillion kilometers, or 25 trillion miles away. Many other stars are even farther away than Proxima Centauri. Despite their vast distance from us, those twinkling stars continue to fascinate us. In fact, worth noting that most stars are between 1 and 10 billion years old. So what up next about the science of stars? Over the years, astronomers have been challenged to learn more about stars. Since stars are light years away, this is a difficult task. Research shows that stars are huge balls of burning hot gases. The main chemical elements that make up stars are hydrogen and helium. So you may remember those are the same gases that make our sun, because our sun is a star. These elements form clouds and collapse into stars due to gravity. Astronomers are still learning about stars and are trying to figure out ways to organize their information. Classifying stars. In order for people to understand and learn more about stars, astronomers define and classify them, or group them based on their characteristics. They group stars by their size and by their temperature. Stars that are the size of the sun or smaller are called dwarfs. Stars that are 10 times the size of the sun are called giants. Supergiants are hundreds of times larger than the sun. To your eye alone, stars may look completely white. But when seen through a telescope, we can see that stars come in many colors. The color is related to the star's temperature. The hottest stars appear blue, and the coolest stars appear red. There are also white, yellow, and orange stars in between. Analyzing stars. Astronomers also classify a star's luminosity. Now, what is luminosity? Luminosity rates the amount of light a star emits. The amount of light a star emits, or gives out. This depends upon the star's size and temperature. It also depends upon its distance from Earth. They also classify a star's apparent brightness. This is how bright a star looks from Earth. An ancient Greek astronomer named Hipparchus developed this system. He named bright stars magnitude 1. The next brightest stars that can be seen through a telescope were magnitudes 2 through 6. So magnitude 1 were the brightest stars, magnitude 6 were the dimmest or the least bright stars. There are several factors that affect how bright a star appears: the star's size, the star's temperature, and its distance from Earth. For example, the Sun is much smaller than many other stars, but it is the brightest star when seen from Earth because it is the closest to Earth. Makes sense. Astronomers also use measurements to determine the chemical makeup of stars. Even though a star may be classified as having a certain color, when its light is shown through a spectrograph, it splits into a spectrum of colors. Each star has a different spectrum. Astronomers can read the spectrum to determine each star's makeup. Now, it's worth noting Annie the Amazing Astronomer, she was the one who came up with that method for determining what stars are made of by looking at their color spectrum. Annie Cannon was an astronomer who found the color spectrum for around 350,000 stars. This was more than anyone else had found during that time. She was able to classify 3 stars in 1 minute without the use of instruments, and she created a catalog of 300 stars to document her findings. So very impressive astronomer she was. Star Saga. Stars are not living things, but astronomers often talk about them as though they are. The story of a star is one of balance. Gravity and the energy a star creates play tug-of-war with the star. Eventually, one of these forces must win. A star is born. Stars begin as giant clouds of gas and dust called nebula. They are mostly made of hydrogen gas. So that right there is a big nebula right there. These huge clouds are like star nurseries. One nebula can produce hundreds, sometimes even thousands of stars. Slowly, gravity pulls gas and dust from the nebula together into clumps. As the clumps gather, its gravity grows stronger. This draws in more gas and dust, and the clump begins to spin. Over the course of about 100,000 years, the spinning cloud gets hotter and thicker. Finally, it gets so thick that it collapses into a ball called a protostar, almost like a baby star. The dust and gas gather together as the center heats up. When the center reaches 15 million degrees Celsius, or 27 million degrees Fahrenheit, nuclear fusion begins. As the core of the protostar begins to burn, a star is born. Balancing act. Once nuclear fusion begins in a star's core, or in its center, it is considered a main sequence star. This is the stage in which a star spends 80 to 90% of its life. The fusion in the core of a star generates a massive amount of heat and energy. This pushes the star outward and stops gravity from collapsing it any further. The star is now balanced between the outward pressure released by nuclear fusion, so the force pushing out from the center, and the inward pull of its own gravity. So gravitational force is pulling inward. As long as those two forces are in balance, the star will stay alive. These balanced forces keep a star about the same size for the entire main sequence stage, making the stage of the star's life the most stable. A star will remain in its main sequence stage for as long as it has hydrogen to fuse. This is different for different sized stars. Large stars have more hydrogen, but they burn through it much faster than smaller, more efficient stars. The largest stars, therefore, actually have the shortest lives. Eventually, their supply of hydrogen dwindles, as stars will run out of fuel, but their deaths can be even more spectacular than their lives. By the way, there's a good image of what nuclear fusion is. Got a bunch of hydrogen atoms inside the core of a star. Under intense heat and pressure, those hydrogen atoms will slam together and fuse to create helium. And it is that fusion of hydrogen atoms into helium atoms that releases all that heat and energy, which is what fuels the star through its entire life. Violent deaths. With no more fuel to burn, fusion in the core of a star stops, and gravity begins to win the stellar tug-of-war. But the death of a star depends on its size. Smaller stars collapse into themselves and become extremely dense white dwarfs. Medium-sized stars, like our Sun, expand to become red giants. After a few 100,000 years, their outer layers expand outward, leaving behind their cores as white dwarfs. so our sun will become a red giant one day, and then a red dwarf. The death of a large star comes with terrific force and makes for quite a show. When a star 30 times the mass of the sun dies, it explodes into a massive supernova. It's a supernova right there, big explosion. It flings dust and particles from the star's outer layers far into space. Eventually, these star fragments get recycled. They become the building blocks in nebulae and are reborn as stars and planets. So all the gas and dust released from supernova can themselves end up coalescing into new stars. After a supernova blast, a star may collapse into a neutron star. A neutron star is only a few kilometers wide. It's so dense that one spoonful of it would weigh as much as a mountain. If the star is more than 30 times the mass of the sun, the supernova turns into a black hole. This super dense object has so much gravity that not even light can escape it. So that's why they would be black holes then, because even all light that gets near one gets sucked into it. Galaxies. Stars collect together with other debris, gases, and dust to form galaxies. Galaxies hold these objects together. Or gravity, holds these objects together. Scientists can see far-off galaxies thanks to the light that shines from so many stars. The famous astronomer Edwin Hubble classified galaxies into 3 types: elliptical, irregular, and spiral. So first, elliptical galaxies. There's a picture of one right there. Elliptical galaxies are usually round in shape. They are made only of older stars. Elliptical galaxies are not nearly as bright as spiral galaxies, and most are smaller in size. They may contain just a few thousand stars, and it's common for the stars to be close together. This can sometimes make the galaxy look like one gigantic star. It's not really, but it may look that way. Next, irregular galaxies. So there's a picture of one of those. Irregular galaxies are not round or spiral in shape. These galaxies are usually misshapen or formless, kind of a random blob shape. Scientists believe these galaxies may have once been elliptical or spiral galaxies, but have lost their shape over time. They may have crashed into another galaxy, or may be pulled out of shape by the gravity of nearby galaxies. So one thing I think is worth pointing out here is how many stars are there in galaxies? Galaxies hold hundreds of billions of stars. Scientists estimate that there are over 100 billion galaxies in the universe. Currently, NASA estimates that there are about 1 sextillion stars in the universe. That's a 1 followed by 3, 6, 9, 12, 15, 18, 21 zeros. That's how many stars there are in the known universe. It's pretty crazy. And lastly, so there were elliptical galaxies, irregular galaxies, and now we have spiral galaxies. Spiral galaxies are shaped like pinwheels, like this, at the center of a flat disk shape made up of older stars. Twisting arms extend from the center. The spinning motion of the arms gives the galaxy its spiral shape. The waves of the arms create very large new stars. The great light of these large stars makes the nearby dust clouds grow brightly. Our own galaxy, the Milky Way, is a spiral galaxy. It's home to us, our sun, and another 100 billion stars. It's 100,000 light years across and rotates once every 200 million years. The center is loaded with stars that surround a very large black hole. These stars stretch for 15,000 light years. The Milky Way is so enormous that several smaller galaxies orbit it. Talk about huge. Indeed, absolutely huge. So our sun is just one of billions of stars inside that galaxy. The center of the Milky Way is hard for astronomers to see. This is because clouds of dust and gas block their view. Scientists believe that there may be a very large black hole at the center of the Milky Way. This massive black hole has super powerful gravity. It swallows anything that wanders into its territory. It's a good thing we're thousands of light years away. Indeed, we wouldn't want to be sucked into that giant black hole. Our solar system. Our solar system is one tiny part of the Milky Way. Our own star, the Sun, lies at the center of the solar system. All other materials revolve around the Sun. As the Sun was born, gases, dust, and rocks swirled around it. They crashed together to create planets, moons, asteroids, comets, and meteors. The Sun is by far the largest object in our solar system. It contains 99% of all the material in our solar system. The sun's gravity keeps planets, moons, and other objects in orbit. Each of the 8 planets in the solar system is unique. They have different properties, colors, and sizes. The inner planets are much smaller than the outer planets. This is because of the location of the planet when it formed and its proximity or distance to the sun. Heat from the sun burned up the gases of the inner planets. The outer planets, however, were further from the sun and did not lose their gases, making them larger. So the inner planets would be Mercury, Venus, Earth, and Mars, and the outer planets would be Jupiter, Saturn, Uranus, and Neptune. Lucky for us, the sun was the exact right distance and size away from Earth to allow our planet to have liquid water. That's why Earth is the only planet to have water on it, as far as we know. Scientists think that this is one of the main reasons life was able to develop on Earth. We still rely on the sun's energy to sustain us. Our solar neighbor in space makes life possible. Star studies. Long ago, the sky was clear. Stars were easy to see because there were no bright city lights. Thousands of stars sparkled across the velvety blackness of night. Stargazing was popular entertainment. Today, it is much harder to see stars. Pollution and electrical lighting dim the twinkling starlight. To see many stars, we must venture outside the cities that most of us call home. Astronomers have developed powerful telescopes and special devices to see stars. These instruments allow people to see stars not visible to the naked eye. Some of these huge telescopes are larger than a school gym. Many are built in remote mountain areas far from the bright city lights, where the air is clean and the night is dark. These stellar lookouts are the best places for studying stars. If you can get out on like a mountain in the middle of nowhere, you're going to see all kinds of stars up there, far away from the city. Other powerful telescopes float in space. Without Earth's atmosphere, these machines are able to peer deeper into space than Earth-bound telescopes. These telescopes collect photos and other kinds of data. They help astronomers learn about thousands of distant stars and galaxies. Okay, last page. Scientists are always looking for new ways to study and explore space. They hope to learn more about how the universe began and how it has changed since then. They want to piece together the history of the universe. They're also on a quest to see if there are other forms of life on other planets, or if we are alone in the universe. They have identified several planets that are similar to Earth, but they're too far away for us to reach. Astronomers and engineers are looking for new ways to power spacecraft. One idea is to use solar power. With an unlimited supply of energy from the sun, spacecrafts could travel much deeper into space. In the meantime, you can learn about stars yourself. All you need is a clear, dark night away from city lights. Bring a star chart or use an app to help you locate stars, constellations, planets, and even galaxies. Keep studying the night sky, and maybe one day you will make the next great discovery. So that was our science ebook on stars. Thank you so much for joining us in the reading today. I will see you in the next one. Take care, everybody. Goodbye.